Hey guys, in the previous orthographic projection video we worked with some regular everyday objects that we can find around the house. We laid out our vertical plane, our horizontal plane and our invertical plane. We saw them all laid out in SolidWorks, and then we worked on projecting the various views of an object onto the planes. After adding in our few notes and our color, we folded up our planes and actually put the whole thing together. And as a result of this, I suppose we can start to get an understanding of what orthographic is all about, and the way that we can transform a three-dimensional object into a variety of two-dimensional views. Every view giving us two true sizes, either the length and the depth, or the length and the height, or the depth and the height. 2D, three 2D views giving us all the details we need for a 3D object. Just in revision of this, when the object is put into the planes, if you look down from the top, the view goes in the bottom. Just like with this object again, when we looked in from the left, the view was pushed over through the object onto the vertical, and it ended up over on the right. So that's just the only little bit of understanding I really need to bring forward. If you look down from the top, the view goes in the bottom. If you look in from the left, the view goes in the right. If you looked in from the right, well, my plane would be needed over here on the left. We're going to take it on to some more difficult objects now. These ones here in particular. And if I just zoom in a little bit so that we can see the specific drawing I'm going to do from this sheet is this one here. So that drawing, all the measurements are quite regular. We can see it's 25 and 50 total height and 75. This is an activity that can actually be built up with little bricks. What we're looking at is this. We're looking at an elevation A. I'll just take note of that. So it's the elevation A. We're looking for end elevation B. And we're looking for a plan C. So three views, all structured on the page. This time we're not going to draw the three planes. We're not going to put in the vertical, horizontal and the invertical plane because there is no need. We're just going to structure our three views on the page. The best way to start these off is by adding a little bit of colour. If we can add a bit of colour, if we can visualise ourselves standing there, seeing this, and add a little bit of colour to what can be seen from each location, then it makes it so much easier when we go ahead and start drawing after. So I'll just zoom out just a small bit, and first off, I'm just going to draw a little person here in position A. And this is their left hand and this is their right hand. Okay, so very important that we have to be able to kind of visualize exactly what's happening, what's on your left and what's on your right when you're viewing from a particular position. So as I view this object, well, the first thing I can see that's right here in front of me would be this vertical surface here, and that vertical surface is 25 millimeters tall. It's the measurement given up to this whole surface here, which includes that front. It's 25 tall, and the total length of it, if I just make my way back to the back, the whole length of the object is 75. So 75 long, 25 tall. What else can I see? I can't see this one. It's in line with my vision. We can't see it. If I jump up to the top, I can see this one as well. So this one is what? I'll just work back here to figure out my measurements. It's 50 millimeters along this way. And how tall is it? The measurement isn't given out here. It's given over here as 25 again. So there's a bit of practice here in getting used to reading the measurements as well, what they're pointed at. Another important thing, but I'm sure everyone's used to seeing this now at this stage. Another really important thing is this. The measurement of 25 here is pointed using the dimensions and arrows at two lines. It's at a line called the leader line that says, okay, the top of this measurement is referring to the top surface because it's all flat. The bottom of this measurement is referring to this bottom surface. So the difference in height between this bottom surface and this top surface is 25. From position A, when we're standing here, on my left hand side I'll get this 125mm line, on my right hand side I get a 25, but I get another 25 block standing on top, and on my left hand side I have a free space here, so I need to have a think about that. I don't need to add any more colour. That's it. That is all I can see from position A. If we move ourselves around, we take ourselves from A and we walk around to this side here and we stand here and we're looking in at the object again. Well, that's my left hand, that's my right hand. So to get the colours again, this time as I'm looking in, the first thing I can see is this surface here. And just so that I can get familiar again with measurements, that surface, well, it's the same height as the green one at the start. They're very same height as that first surface, 25mm. The length of it, if I start looking what's the total length of the object, I'd start looking, none of them, they're all, or sorry, I should say they're the lengths in green, and this is the widths here, and then we've heights, so lengths, widths and heights. So the widths are all shown over here. Total width of the object is 50, so it's 25 for the top block, 25 extra, so total 50. What else can we see? Well, on the left hand side, up tall, up high, up here, we can see an extra orange square, just like that. So I think that's it. I can't see this flat surface or this flat surface because they are completely level. So from position B, looking at an end elevation of the object, that's what I can see. On to the next one. Now this one takes a little bit more imagination. We're hopping into the helicopter, we're going up in the air, and we're going right up, and we are looking down on top of the object. So I'll just draw, there's my eye right there, looking down on top, in line with the arrow C. So what can I see this time? We'll grab a different colour and we'll add it in there, and what we can see is just two surfaces. I think this is often the easiest one to visualize. Whatever is up at the top, it's the roof of the building is what we're looking for here. It's these flat surfaces up at the top. So we have this guy right here, and this time the two dimensions we're seeing is the lengths and widths. We can't see heights from looking down on top at a plane. So we can see that blue surface there as well. Now the collection and organisation of these three views together, the green view being the elevation, the orange view in from this side, the end elevation, and the blue view down on top being the plan. The collection of those three views is going to give us all of the information we need for this three-dimensional object. Now, just fold that sheet in half and leave it there to the side of my drawing board so that it's still visible, and actually bring it right down just to that one question that we're working on, and we'll start drawing. First thing I want to make sure is I want to make sure that the drawing fits on my page, first of all. So I'm going to start off here up on the left hand side. I'll just zoom out a bit so that this is all visible now again. So I want to make sure that my three views, my elevation A, my end elevation B, and my plan C all fit on my page, and they will because it's quite a small drawing. Starting point for this drawing. From the top of the page I'm going to come down 80mm. I'm just going to move that page just off the board so my T-square doesn't get caught there. So from the top of my page I'm going to come down 80. And from the left hand side of my page I'm going to measure in 40. That's the start point of my drawing. The line I just drew, and I'm going to just try to make sure if I can this stops maybe just about halfway in the page, and I might be able to fit a second drawing in this page. The line I just drew is the XY line. So that's the line of intersection between the vertical and horizontal planes. The point I just had here, down 80 and in 40, is the starting point of my drawing. It is the first point on the elevation. So where is that? Well, when I'm looking in at my elevation, on my left hand side, down the corner, I have this point right here. That is where I'm going to start. I'll start off by building this first green surface, which is 75 long and 25 high. So that's where we'll get this question off to a start. I'm going to measure 75 along. I'm going to draw two light lines, standing up, and that first surface, as I said, is 25 millimeters high. That's the top of the surface, the bottom of the surface, and the left and right side. Now, one surface done. To bring this guy back in, what we need to visualize this time is which side is the block. So I've just drawn up, I've gone across, I've gone back down and across the base. And here on my right hand side, up top, I can see this block. Now, the interesting thing about this is that this line and this line, they're all part of that same back face of the object. They're the same surface of the object, so they appear as one single straight line. All of this detail right here, an extra 25 millimeters tall. So I'll build that surface up top again, and from 100 up to 125 is my 25 millimeters extra, and the length of that top surface was 50. Now, first view done, we can take a minute to add in a little bit of colour there as well. Now I'm just going to add just that little bit and I'll finish it after, but you can go ahead and add all the colour now. Pause the video and add in all the colour. So there's the first view complete. View A, looking in this position, we get our first number one surface here down low, and we get number two, this green surface here up top. If I just want to add it, maybe add in the note here again, and this is the elevation. And the elevation is the name of the view, and the vertical plane is the name of the plane that it's drawn on. Next, last time we worked with our matchbox, we worked from the elevation and we worked down to the plan. So all the lengths that were marked in the elevation are projected straight down to plan. That saves us having to measure everything all over again. The plan in this case is the blue. So looking down from C, the blue detail. If I just put that to the side again, I have all of my lengths marked. So all I'm going to do is take all the positions I've already measured and project them down. I'm also going to take this top position, and I'm going to take this left one. I'm going to leave a space between my views of 10 millimeters today. What I need to figure out now is I need to figure out what this plan looks like. And this is really where the little test in visualization comes in. Can you visualize what's happening? First of all, when I'm up here in the air, the whole back of the object, although it does get cut off and there's a section missing here and here, well, the back of the object is still perfectly flat. I will then be able to see this on the right hand side, the object never moves, don't forget, the object doesn't move, we just move as we're looking at the object from various positions. At the right hand side, I will be able to see the top surface, 50 long and 25 deep, and then I'll be able to see the remaining surface, which is a total of 50 deep. So if we just see what that looks like on the drawing. The back surface of the object, one full solid line. I know that the two depths that are given are, oh sorry, I marked 15 by mistake, 25 and 50. So there's a 25 given and a 50 given. I'm going to just add them both in light first of all. There's the 25, there's the 50. And now I need to just figure out where is the division between my two surfaces. So before I do that, I can actually outline the whole object, because I know that the front of the object is fully solid. I know that the left side of the object is fully solid. And the same here on the right. So, object is outlined. Now, what I'm working on is this. I'm looking for the outline of the top surface. It's on my right hand side as it was in the elevation, and it's 25 mil down, and then I can outline that. So on the right hand side, 25 mil down gives me the outline of that blue top surface here and here. So once again, we'll add a little bit of colour. I'll pause the video, go ahead and add the colour, and then we'll number our surfaces and reference that to our little three-dimensional drawing, and we'll take it from there. Now, there's the blue colour added onto the top surfaces. If we wanted to just number this, and again, it's the only purpose of this numbering maybe is just when you're at these initial drawings, help with understanding and visualising everything. To number this, I might call this very, very top surface, surface number 3, which is here, surface number 3. And the next one down is kind of an L-shaped one here. I'll call that surface number 4, surface number 4. As I said, this numbering is not going to be necessary in future. This is just to get used to the original drawings. Now, we're going to change things up just that little bit. So the last video I had, we left a little bit of space. We had our X, Y line, and then we had our Y, Y line. But basically, the object itself, the box of matches, was sitting on the ground. But we left a bit of space here. Well, this time we're gonna move the planes, and we're gonna move them over until the object is touching the Y, Y line. And that's going to save us just that little bit of work here, and we'll see why in just a second. So the object is touching the Y, Y line. Now, what does that mean for us? It means that that right there is the Y, Y line. The last time, this is what we did, and we'll still do the same first step. The first step is not going to change. We don't want to have to measure the 25 mil height again. We don't want to have to measure the 50 mil height again. So we project them straight across the page, just like the previous time. But the only difference is this: in the previous example, when we had our object sitting down on the ground, we projected along, and we hit the YY, and then we went up at an angle along to hit the YY. This time we're already hitting the YY line, so there is no need to project along. It just saves us that little bit of time. What I didn't mention in the previous video, and I don't mention this at the very beginning, but a way to project all of our distances. So we had a 10, a 25 and a 25. We can actually use the compass. So we can use a compass, and that compass shows us the fold out. It shows us this happening. It shows that movement actually happening on paper. It's with the compass. But as I did say in the previous video, the more accurate way and the faster way is probably going to be just take your 45-degree set square and project it up. Either way, you end up at the exact same point. Follow the same process for the two other points. And that's going to give us, from the points that those land on the XY line, it's going to give us 1, 2, 3 projections. Okay, to focus back in on our question now, so that we can get an idea of what's happening here. We're now, after moving ourselves into this position, so we were at A, we actually skipped B, went up and projected our plan. Usually we draw the elevation first, the plan second, and the end elevation third. That's our usual way of doing it. We are now standing right here in this position. Everything we can see is orange. We cannot see the green, we cannot see the blue. So it's just the orange detail this time. The first surface we can see right here in front of us, and we've already used numbers 1, 2, 3 and 4. I'm going to call that number 5 and then that number 6. Number 5 is 50 long, or I should say wide, of course, because we have lengths here with our heights and these are widths. So it's 50 wide and it's 25 high. And this number 6 is 25 wide, because there's the measurement given to me. 25 wide and 25 high. But the good news is I don't have to measure anything. All my measuring is done for me. I did it in my last 2 views, so I won't do it again. The only thing we do have to realise is that number 6 is on the left. The most common mistake made at this point is putting number 6, this top surface, at the wrong side. Let's just have a look back in at our main drawing, and we can get the H pencil because we should be ready now to start heaving in some detail. Number 5, this main orange surface, is here. When I was looking at number 1, number 5 is there. I project across, it's all the full width of it here, so I can draw that one in. So right there, that is surface number 5. Now, as I said just a moment ago, the mistake that I'll see very, very often here is that number 6, someone is going to forget about their lefts and rights and put it up here in this corner. It's not possible. If we look at the elevation, well, that right along there is an edge view of number 6. We know that it starts at this height and finishes at this height, which is fine. It could be any of the two, but we work down to our plan. There it is. And if you project across and up, this has to be here. There's no other place for it. So number 6 has to be right there. Now, once again, I'm going to just quickly pause the video, get this shape coloured in with the orange, just to reference my 3D, and then we'll have one final look at the drawing before we finish up. So what we can see here now is the complete drawing. We have, I'm going to just add in just that little bit of weight onto the X, Y line that goes across our drawing, including this point, of course, our X, Y line going across, and in this particular case we put the object up against the right wall. We took it right in up against the vertical plane, so that's our Y line all the way down. We have now seen why it's important to be able to visualize what's happening, see what's on your left, what's on your right. We've also seen how different arrangements of objects can be seen in our views. There's more practice questions to do at this stage, and the next question is just going to up the level and up the difficulty just that little bit.